So hello guys, today we want to discuss on one of the topic of data structure algorithm, that is sorting. And here we are particularly going to see on the two type of sorting, that is merge sort and the bubble sort. So guys, this is me Bijendra. I have in front of you RA number 2073, especially focusing on the bubble sort. So let's go ahead. So here we can first we have to get the idea what sorting means. Sorting means directly a simple idea of arranging an element by ascending order or descending order. So the basic idea is like this. Just scattered element will be arranged in either ascending or descending. Right? If the data is scattered, it will be arranged in an order that the user will give. So how can we do sorting? So first, I particularly want to discuss on bubble sort. So bubble sort is a simple sorting algorithm. It's a sorting algorithm. It repeatedly steps through list. It will go each and every element and swap the element if the element is smaller or bigger than the first element, depending upon the order that user is giving. But it's a brute force sorting algorithm. That means it is not very efficient for large list, but is easy to understand and implement. Like you can take example of using this algorithm. Like you can see there is an array given. The loop will be starting from I to 0 to I to the value the index of the element. And the first element will be considered I is equal to 0 and it will be increased one by one. And the second element will be considered I plus 1 such that the first element and second element and their adjacent element will be close to each other. And if the element is like if you are looking in the ascending order, if the first and second element, if first element is bigger than the small second element, then it will be swapped, and vice versa in descending order. So what's the time complexity and space complexity? Time complexity and space complexity. Time complexity is the binary square in every condition called two loop will be executed one after another. So that's why time complexity of this square and then space complexity is going on. So this is the code implementation. Here we can directly see how there are two loops going on. That's why the complexity is O n of square and there is a swapping going on. So we have made the comment swap. So now I would like to call my friend Roshan to give the further explanation about merge sort.
Hello, thanks to my friend Bijendra. My name is Roshan, RA number 2079. I'm going to explain merge sort. Divide, take an unsorted list and divide into two whole levels. Keep dividing it on this until you have seen a smaller sublist with just one or zero elements. Compare. Now start sorting. Compare the elements in the sort. Divide sublist. If there are two elements, put them into the correct elements. Put them into the correct order, ascending or descending. If there is only one element or the sublist is empty, it already is sorted. Merge. Once you have sorted the smaller sublist, merge them together, combine two sorted sublist into a large sorted list. Keep doing this until you have one single sorted list that contains all the elements.
So hello guys, before going to that, I'll just try to explain that from this example. So here in this sort we have given one array. So in this array we have to sort this using the mod sort. So for this first, rather than from that bubble sort normal method, we have used the mod sort to reduce the time complexity. Although it increases our space complexity for efficiency for time complexity, I have used this mod sort. So let us go with this example. So here in this example you can say there is one array which consists of the 1 2 3 4 5 6 and 7 elements. So first in this mod sort there are the mainly two steps. First one is divide and second one is conquer. So in the first step we have to divide the whole array into half, or so let us suppose in this there are 7 elements. So while dividing it by it consists of one part consists of 4 elements and another part consists of 3 elements. So the first part consists of 4 elements 38, 27, 43 and 3 up to that mid one, and that the next part consists of 3 elements. So we have to divide this array until that it gets a single separate array. So I have divided this for the first time, then I get these two arrays consist of first array consists of 4 elements and second array consists of 3 elements. So again I have to divide these two arrays until I get the single array. So when dividing this array which consists of 4 element, I get array of element 2 2. So this gives array with which consists of element 2 38 and 27, and next array 43 and 3. So again dividing the next part, which is the right side of the first divided array, which gives us to array consists of the 2 element in the first array and single element in the second array. So this consists of single element, right? So I have to leave this alone, and I have to divide the other remaining array until they get the single element. So I am again dividing these elements, these arrays until they get single elements. So in these steps I get all array element as single element. So I have to leave the my dividing part until this my dividing part is completed. So now I have to just concord them or just merge them all. So like I have to sort, it's easy to sort the single element rather than sorting the whole array. So we have divided this to reduce our time complexity from o n square to o log n into log n. So first I have to just compare this to 38 and 27, right? When comparing 38 and 27, like 27 is smaller than 38, so 27 goes in the left hand side of the 38. And similarly I have to compare these two terms. When comparing these two terms, I get the 3 is smaller than 43, due to his 3 gets in the left side of 43. Similarly I have done same comparison and just swiping them according to their position for this all this term. After that, so like you see that 27 is smaller than 38. Similarly 3 is smaller than 43. So these terms are like already sorted, right? So I just have to compare that 3 with 27. So when comparing 3 27, I know that 3 is smaller than 27 due to its 3 got in front of 27. Again I have to compare 43 with 38. So 38 is smaller than 43 due to which 38 come like before 43. So I can sort these two arrays. Now my task is to sort like that right hand side of this array. Similarly similarly, so I have to first compare this 10 with 9. 9 is smaller than 10, so 9 comes front of 10. Like there, like 83 is left alone, so 83 is at the end. Similarly I have to compare this right hand side with the this left hand side, and I have to sort them. So my first element is 9 and 3. So 3 is smaller than 9, so 3 comes here. Again I have to compare 9 with 27. 9 is smaller than 27, so 9 comes here. Now 9 I already sorted, 3 has already sorted. Now my task is to compare 10 and 27. So 10 is smaller than 27 due to its 10 comes here. Similarly 10 is also completed. Now my task is to compare 27 and 82. So 27 is smaller than 82 due to 27 comes here. Now my task is to compare 82 and 38. So 38 is again smaller, so 38 come here. Now 43 is again smaller, 43 come here. At last I left with 82. Due to which 82 like left here, and my array is sorted. So due to which first I have divided the whole array into smaller part until they get into single elements. After that I I merge them into a single array. So I get the one sorted array into the less time complexity. So going to a time complexity, this time complexity o n into log n, because for every step I have dividing the array into the to have, due to which my time complexity becomes n into o log n. Now going toward the space complexity, it's space complexity o of n, because I have to store whole I have to store the sorted array, and I have to first make one array, and I have to store every sorted array in this array. So its space complexity is open. So in conclusion I can say that if there is the scenario like we have to reduce the space complexity, I do not refer you to go this with this process. We can already go with like our bubble sort, simple other sorting technologies. So if there is the like scenario where we have to reduce the time complexity, we will definitely refer this process. So going towards slides, like that's okay. Now going towards that PPT, you say that the same process, that's like the array consists of 6 element divided into 3 3. Then after 3 1 and 2, after 1 and 2 1 on, and just merge that. So that's all I have already explained. Now I have to first go with the divided part. It consists of like one static index, one ending index, and one array. So static index is the static index of our array, which should be always smaller than our ending index. If it got like larger or the smaller, if equal to the our ending index, that means that we are in the single element of our array. So this is gonna our base case. Now we have to just find out the mid element of our array. So there is one variable named mid, which is to find the mid element of our array. Then we have to go till the single element of our array. So we have to we don't want recursion of here. So which one recursion is from our array beginning to the mid element, consists of the first part of our array, and then second recursion is from the our from mid to the ending index, which is our the right hand side of our array. That means that the second part of our array, this going on till our static index is greater than or equal to ending index. So
And now moving on to the conclusion part. Hence, in comparison of normal bubble sort, which is entirely brute force sorting algorithm, in nature we use the concept of merge sort. It revolves around the concept of recursion and is primarily focused on divide and conquer method. Now exploring the time and space complexity of our project. The time complexity of our project is O of n log n, and the space complexity of the project is O of n. Now, the use of bubble sort and merge sort is entirely scenario based. However, we must understand that one. Now, moving on to the scenario-based uses. However, we must understand that the use of bubble sort and merge sort is entirely case dependent, depending on our time and space requirement. If we